if I tell you that there is a point P here, whose coordinates are x, y, right? You can, obviously, because that is point P given in coordinate form, for us to measure x and y, we should be starting from the origin. So we need to start from the origin, so I'll draw a line to the origin. Okay. So this is like, I'm actually drawing something like a circle if you want. So that could be the radius of the circle. That is the radius of the circle. And then I want to draw a right-angled triangle, dropping this line from point P, and we need the 90 degrees to be on the x-axis. Do you then agree that starting from here up to there, maybe let me call this point A, the length of OA is equal to x, we agree, right?
Yes.
And the length of AP is equal to y, right? Then you can use Pythagoras theorem to work out the connection between x, y, and r. You know that? So using Pythagoras theorem, what is r squared equal to? This will be x squared plus y squared. So this is just your simple Pythagoras theorem. So r squared is equal to x squared plus y squared. So this is one thing that is going to be very important, of course, in this topic. Then I want us to assume that the angle that is formed between the line OP and the x-axis is theta. So that angle there is theta. I think you gentlemen should find another place. You're sitting right at the corner. You can't see right now, right? Right. Then use your definitions from grade. From grade 10, was it 10 or 9? What did we say sine of theta was equal to?
Hypotenuse.
One at a time, please. And you know, between a question and an answer, there should be a decent break. I mean, we need to process the questions first. What is the sine of theta equal to?
Opposite over hypotenuse, which is y over r.
Okay, so this is the opposite side divided by the hypotenuse, which is, in this case, if your angle theta is the angle that you are using, then do you see that y is actually the opposite side, and r is the hypotenuse. So we can write this as y divided by r. Okay, then cosine of theta? Yes.
This is adjacent over hypotenuse.
Adjacent over hypotenuse, yes, which is,
x over r.
in this case, this would be x over r. Okay. So this is x over r. And then tangent?
Opposite over adjacent.
Opposite over adjacent. Okay, opposite side divided by the adjacent side. And in this diagram,
It will be y over x.
it will be y
Over x.
over x. So it's y over x. So we know all that, right? And you probably remember the mnemonic that you use. What did you use? So katoa. Okay, so katoa. You can change that and make it your own, like you can develop your own one. You don't have to say so katoa all the time. Yeah, you can be creative and create another one for yourself. So katoa. Then do you agree here that in this quadrant, remember this is called quadrant 1, and this is quadrant 2, and this is 3, and this is 4, right? Okay, how many degrees is it here? It's 0 degrees there. And how many degrees is it up here? 90 degrees. And how many degrees here? 180 degrees and how many here? 270 degrees and back there, 360 degrees. So remember all those things. Maybe the other thing is, do you see that we are measuring our angles in an anti-clockwise direction? We're starting from 0 and we're counting 90, so that is anti-clockwise. So when you measure your angles anti-clockwise, your angles will be positive. So all positive angles are angles that are measured anti-clockwise. If you measure clockwise, if you measure this way, like from here to there, like how many degrees is it from 0 degrees here up to here? This way, clockwise. I mean clockwise.
90.
From here to there, it's 90 degrees, right? But how do we write it? Do we write 90 degrees? We write minus 90 degrees. So if I'm measuring this way, I'll say minus 90 degrees. So this is minus 90 degrees up to here. Then it's minus 180 degrees up to here. Then it's minus 270 degrees up to there. And back to your minus 360. So measuring clockwise, your angles are negative. But measuring anti-clockwise, your angles will be positive. I know we mainly measure anti-clockwise. Right, so if we do this, guys, tell me about x. Is x in this quadrant positive or negative? So x here is positive. What about y here? Again, y is positive. It's going up, right? And then the radius, do you think the length of arrow will be positive or negative? This one is always positive, so it is positive here, right? Right, so do you understand now why in this quadrant, the sine of theta and the cosine of theta and the tangent of theta will always be positive? So sine theta, cos theta, tan theta will be positive because to get sine theta and cos theta and tan theta, we need to be dividing these numbers. But all those variables are positive. That is why the ratios are all positive in the first quadrant. And I guess you guys then put an A there to say all of them are positive, right? Okay, now let's go to this point here. Suppose our point P, I'll call this one P. Because I call that one P, I can call it P. We are allowing P to move in a second. Now suppose P is here. If P is here now, how do I get to P? Remember, you have your radius there. The radius will always be positive. Then you need to draw your 90 degrees on the x-axis. So for me to get here, I move along the x-axis to the left, and I move along or parallel to the y-axis upward. So do you see that x is now negative here? But y is positive, right? So this point is minus x and y. Then if you use the formula, sine of theta, because you now need to take this angle there as your theta. Just take that angle there as your theta, but we are actually measuring from 0 degrees. So it's from 0 degrees up to there. So that angle now is obtuse. Yes?
I was going to say that isn't R always positive? It was already said by some.
Yes, R is positive, right?
Yes, sir.
Okay, so please take note, R is positive. What about y? Y is positive and x is negative. So sine of an angle that is here, sine is y over r. So it's y over r. Do you see that this will give you a positive?
Yes, sir.
But cosine is x, but x is negative over r. So cosine here is negative, and tangent here is negative. So that is why we put s here, and s means only sine is positive in that quadrant. You could actually move your point P to this point. If you do that, now this is like your radius, and you can draw your 90 degrees here. Now x is horizontally to the left, so it's negative x, and your y is vertically downward, so it's negative. So do you see that this is now minus x minus y? Right. So x is negative still, and y is also negative. R will always be positive, yes.
So what does that A symbolize? All are positive.
or the A is telling us that all these three ratios are positive in this quadrant.
And only sign is positive in that quadrant.
And S means it's only sign which is positive in this quadrant. In other words, cosine of an angle that is here is negative. And tangent of any angle that is here is also negative. But sine of any angle that is here is positive. It's only sine which is positive here. You will discover if you apply the same thinking,
10
it will only be tangent which is positive in quadrant 3.
and
And in quadrant 4, it's only cosine that is positive. So ASTC, or the cast diagram, do you call it the cast diagram?
yeah.
Okay, so if you call it the cast diagram, remember the C is here. And then you can read cast. Otherwise, you can start ASTC. Your first quadrant has A, your second quadrant has S, and so on and so on. Now that information is very important. That is what I need us to use today to answer any questions
We got it.
related to this. Right. Can we look at examples now?
Yes.